Document the creation, operation, and lifecycle management of models and datasets. Why this principle? Data drives the development of an ML model and impacts the model's resulting behavior. Tampering with a dataset can therefore have a significant impact on a system's integrity. However, in many workflows, datasets and models are unlikely to remain static throughout the development and wider lifecycle of an ML solution. This regular mutation can make it difficult to distinguish nefarious changes from legitimate updates. It's therefore crucial that system owners implement a framework for monitoring and recording changes to an asset and its metadata throughout its life. Good documentation and monitoring strengthens your ability to respond when a dataset or model has been compromised, for example, through poisoning. It's worth noting that although datasets are used to produce models, creating an inherent connection between model and dataset metadata, they should be treated as separate entities. A dataset is not necessarily exclusive to a single model, and a model can be trained on multiple datasets. Version control allows changes to be tracked and rolled back, and for metadata to be generated for confidence checking. Tracking changes between versions enables scrutiny between releases and updates and allows developers to understand and mitigate attacks or accidents. This has an overlap with preventing data leakage, where data used to train a model can be accidentally reused in validation. The most significant metadata will vary from asset to asset, and it's for the asset owner to decide what is important to record. The format of this metadata should, however, be standardized because information captured in a consistent way is easier to share and communicate, allowing users to be better informed and make better judgments, which ultimately improves security. Collecting data in a machine-readable format has several advantages. One is that a digital catalog for datasets and models can be created, allowing users to filter and search depending on requirements. Machine-readable data can also be consumed by other programs that can be used as security or monitoring solutions throughout the operational stage of the lifecycle. This can help implement tracking model behavior, monitoring and logging user queries as outlined in Principle 3.2. Deployment. Design for security. Good dataset documentation enables more trustworthy sharing of datasets. Hashing and digital signing of a dataset can ensure that recipients of a shared dataset can verify the authenticity of its contents. What are the goals of this principle? You know the intended use of the dataset, including where it can and can't be used. You know who is authorized to access your data. You know when your data needs to be deleted. You are aware of any biases in your data. You have considered what metadata should be captured and for what purpose. You version control your dataset throughout its lifecycle and can roll back datasets or models easily to help with root cause analysis. If a model is compromised model, you can roll back to a known safe state. You know what data you hold and where it is stored. If you are distributing your dataset or model, the recipients can verify the authenticity of the contents using attached metadata and confirm it hasn't been tampered with. You are monitoring key metrics that can be tracked across the data lifecycle. Strengthen your processes. Consider using version control software, such as Git, to track and control changes to software, datasets, and your resulting model. The size of your project assets, e.g., datasets, may limit your choice of technologies. Larger assets may require more specific database-centric technologies. Guidance. There are a range of version control paradigms and supporting software to choose from. It will be for your development team to select the best for your use case. Though in general, your version control software should be able to track which users make changes to datasets and models with full details of any modification, including the author, time, and date. Allow for reviews before changes to an asset are made. Roll back in case of a security incident where an older version of the asset is required. The UK government has advice for maintaining version control in coding and advice specifically around using Git and GitHub. Track dataset information and updates in a consistent format that is readable by humans and that can be easily processed or parsed by a computer, JSON, CSV. This metadata should be paired with the dataset throughout its lifecycle and include updates to the dataset made throughout operation via continual learning, as discussed in Section 4. In operation, continual online learning. Guidance. Technical implementations for tracking datasets include a data catalog or dictionary, or implementation as part of a bigger solution, for example, as a part of a data warehouse or a version-controlled database. The metadata you track on your dataset should be decided based on your specific application. Metrics that can benefit security may include a description of how data was collected, the sensitivity level of data, key data metrics, e.g. RGB values over a set of images, the dataset creator or maintainer, intended use of the data and any known limitations, retention time of the data, retirement destruction method of the data, aggregated stats about the data, e.g., if labeled, count of each label. Track model information in a consistent format that is readable by humans and that can be easily processed or parsed by a computer, e.g., JSON, CSV. The model's metadata should be paired with it throughout its lifecycle and include updates to the model made throughout operation via continual learning, as discussed in Section 4. In operation, continual online learning. The model cards format is becoming an increasingly popular framework for tracking model metadata, with organizations such as Google using model cards. Guidance. Model cards can be used to track versions as ML models are updated or trained with different datasets throughout development or continual learning through operation. You may choose to create your own model card format. Useful metadata to track for security purposes may include the dataset on which the model was trained, the model creator point of contact, intended scope of the model and its limitations, secure hashes of or digitally signed trained models, retention time of the dataset as per the dataset metadata, retirement destruction method of the model. Note, there are many other things you may choose to track on a model card for different reasons. Here we have just outlined security-related metrics. Once model cards have been created, they should be stored alongside the model. Cataloging the cards in a searchable, indexed format is useful to users and developers, as this allows developers to find an appropriate model easily and to compare models. GCHQ have released a framework to enable this called Balo. More information on how to install and use this can be found on GCHQ GitHub. Strengthen your people. Empower your people with accountability for assets. Accountability can be for the creation of an asset and/or the maintenance of it. Guidance. Ensure your development team follows good development operations management. Operations management is important for security because it covers policy compliance, configuration, and management of development tools, e.g., version control software. This management should continue throughout the lifecycle. Ensure your development team follows good development operations management. Operations management is important for security because it covers policy compliance, configuration, and management of development tools, e.g., version control software. This management should continue throughout the lifecycle. Development teams should include a role that oversees management of development operations. These job titles are usually called DevOps or Machine Learning Operations, MLOps, engineers. Part of the specification for this role should be overlooking and managing digital assets, ensuring that organizational policies around the assets are adhered to. For smaller teams, where there isn't the capacity or requirement for a single person to take this role, make sure that MLOps practices are still implemented and followed by the developers themselves. Training may be required when this is the case.